Hello, students. Getting to the answer key for Module H, and since this one was GeoGebra, just kind of showing a picture probably wouldn't do it justice. So I'm going to go ahead and record this one, and hopefully that helps kind of show you the steps. So we're going to do 1, 7 to 8, 11, and 13. So let's take a look together. And again, just kind of pull down all the way to the bottom on these, and we'll see what we get to. Oops. Question number 1, inscribing a circle in a triangle. So construct any triangle, construct a bisector of one angle, construct a new point on the angle bisector, construct perpendicular bisectors from that point to the sides, measure the lengths, move the point along, drag it along, observe the measure, construct the incenter. Got it. So theirs is pretty detailed, but they're trying to show you that there is a point that would minimize the distances to all of the sides. Measure the lengths of the perpendicular segments using this. So what you're going to see here is, and again, there's nothing wrong with it. So we'll just build ourselves a triangle. There's a triangle. Make sure you go back to the start with a polygon tool. And then we want to make an angle bisector. So I'll take the angle bisector of those two. There it is. Then it said create a point on the angle bisector. So just pick a point on the angle bisector. And now you can move that point. And what they're trying to get you to see is if you create a perpendicular line, so from here to there, and from here to there, then create these points of intersection. Okay. And now what I'm going to do is I'm going to hide some objects. Okay. I'm going to keep the angle bisector, but I'm going to remove these perpendiculars because I think they just kind of clutter things up a little bit. And I'll put in the segments. So I'll kind of draw the segments in manually, just the segment, not the whole line. And now I can use the measure tool to find the length or the distance. So what I want you to notice is, and I'll zoom in a little bit, you can see that from D to E is 1.5, from F to D is 1.5. And there we go. And let me try the settings over here. I'm trying to remember where it is. Do, 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 do. I thought there was one about, that's fine. Oh, here we go. Show label, name and value. Yeah, name and value is fine. Color, style, no. I wanted decimal points. I thought they had those here. Where was, oh, I clicked settings for global. So instead of 1 decimal point, why don't we go out to 5 decimal points? And the reason is I really want you to see that it's not just rounding it. It's not like it's close. These are actually very, very, so as I drag point D out, what you'll notice is the distance to those sides stays exactly the same. Right? No matter where the point is, the distance from those sides stays exactly the same. Okay, so let's check and see. We built the new point, we measured the lengths, we moved the point along, make a conjecture. We conjecture that any point on the angle bisector of angle A will be the same length or the same distance from its sides, the sides that make up that angle. So now what we need is we need to create the incenter. And it's the point where the 3 angle bisectors intersect. Okay, so what we're going to do now is we're just going to go down to angle bisector. We're going to bisect one more angle, and we can see a point of intersection right here. And then what we do need is, once again, we do need a perpendicular to the side, like so, to create a new point. And we need that point to make the radius. So if I build a circle with a center, I want it to touch all 3 sides exactly. All right. Now, all these things up here on top, I might be able to hide because now they're just kind of getting in the way. If you want to be perfectly honest, that's what's happening. So I'm going to get rid of those. I'm going to get rid of point D, and let's see if that clears it up. There we go. That clears it up a little bit. And you know what? Some of these other lines as well. I don't really need the angle bisectors anymore because I've used them to create this. Oops, one more there, that perpendicular. Okay, so now take a look. As I move point A around, because it's the angle bisectors, that circle will always remain exactly touching the three sides perfectly. Every time, no matter what I do. I can try to make this equilateral, I can try to make it obtuse, I can try to make it a right angle, doesn't matter. So that is how you create an incenter. All right, so that's question one. Let's see what was next, 7 and 8. So let's jump down there. 7, inscribe a circle in a square. Find the percentage of the area in the square not covered by the circular region. Then inscribe a circle in a square. Find the percentage of the area of the circle not covered. Okay. Use the answers from A and B to determine whether a square peg might fit better in a round hole or a round hole in a square peg. Well, let's jump over here, and I'm going to save this online as incenter homework number 1. And then I'll just clear everything. Let's get rid of our settings there real quick. And we'll come over and we are going to make a square. So first off, I'm going to make a square. In order to do that, I need to make perpendicular lines. And I'll just make perpendicular lines like so. And then you have a couple options. So, you can kind of choose what you want to do. But if I build a circle from A to B, this new point that I create up here becomes the same length as AB. And so I could just shoot a perpendicular here going across, and that would work. Or you could use the circle tool one more time and go up. Make sure you go from B to A and mark the point. And then you can just draw the segments from there. So B, and just mark all of the segments, and that allows you to hide everything else and just keep it clean. That's all it is. Just sometimes it gets a little bit messy when you have too much stuff going on. Okay, let's take a look at what we have now. We've got a square, and I can move my square with A or B. Notice C and D are not in blue. That's because I cannot just randomly move them. Yes, for this example, I could have chosen a regular polygon. I chose not to. I wanted to show you how to create it. Now I need to make a circle that goes perfectly around this. And the way to do that, or at least the quickest way to do that, is to build a segment, then click midpoint and choose the midpoint. Make that midpoint the center of the circle, and then extend the circle out to the edge. And now you've got a perfect circle going around a square. Okay, so there we go. So what I need now is I need areas. So why don't I build the square into a polygon? Because I can measure the area of the polygon pretty quickly. And so let's see here, area. And I need area of that. There it is, 9.2. Okay, and again, I may need to go to settings. And it says 5 decimal places. There we go. Oh, did I not save the settings? Is that what I needed to do? Save the settings. All right, there we go. So there's the area of that. Now as I go to area, it says select polygon, circle, or conic. I will select the circle, and there's the area E right there. Okay, let's see, can I move that a little bit? Okay, so area of ABCD 9.2452, area of E 14.52233. Okay, now I need a square that goes around this circle. Okay, well, how am I going to make that? I got an idea. Why don't I build a parallel line that goes through the center, and then I'll build a parallel line that goes through like this, and then I can create the points of intersection, because remember, I want my square to just touch, right? Like this. And then I can build some perpendicular lines. So I'll build a perpendicular line from here and there, from here and there. Take a look. I am building perpendiculars, and oops, that point was off. And there they are. Well, sorry. So mark each of these. And watch the color of these. Notice that one J up here? That J point is on the line, but it's not at the intersection. The intersection is dark because I cannot move that intersection. If I move A and B, see how that would move. But if I click on J, it may not be at the intersection. So I actually want to delete point J, and then I'll go through and I'll hide a lot of these lines because I think they just make things a little hard to see. That's all. Notice you did click them once. Once they turn gray, they will be kind of moved away. And let's see here. Is that it? There we go. So again, A and B. So I think my issue is I need that exterior shape now. And you know what? Point G is kind of annoying. No, not that. Okay. I don't know. I don't know what that point is. What is that point? What the heck is that point doing there? Can I delete that point? Maybe not. I just did. Okay, I guess I could, maybe. Let me try to get rid of these points up here. And there we go. That should do it. Oh, of course, I brought something back in. Let's get rid of that one. There we go. Okay, so I've got my circle. I've got my initial square, right? Let me put that right there in the middle. And now I'll build a polygon around the outside, like so, because I know it'll touch exactly once at each of those points. And then I can create the area of that. There we go. All right, let's take a look over here on the algebra side. Okay. Ooh, okay, so I have Q2 is a polygon and the area is 27.9824. Okay, so that's the big square. Q2 is my big square. Let's go up here and let's say M equals area E. Okay, so M is the circle. So let's see here. If I do M divided by Q2, okay, it gives me 0.7845. Okay. So that's from the circle to the big square. So the circle to the big square uses 78.5%. So we're down about 21.5%. Let's go find the other one. And the first polygon is called Q1. Okay, so Q1. So that what I want is I want Q1, which is the inside square, divided by M, which is the circle, and I get 63. Oh, wow. Look at that. Q1 over M is 0.63662. Okay, so yeah, that's not as good. So one of them uses 78%, one of them uses 63%. So in terms of the question here, use the answers to determine. Yep. Find the area and determine whether a square peg might fit better in a round hole or a round peg in a square hole. And let's go back. So what we can see is this one fits better, and that is a circle in a square hole. Okay. So if you're kind of looking at it, trying to kind of put some thought into, well, what the heck is going on here? Well, the issue I think is that there's so much. Look at this whole chunk here, and there's 4 of those pieces, and those are big pieces, right? So again, there's just 4 of those. Whereas on the other side, there's these, and these already look smaller, and they're smaller, and the larger the square is a bigger shape to begin with. So anyway, there's your options. I have not used that tool before. It's called a vanishing pen. That's very interesting. I'll have to think about that. And a smart pen? I don't know what that means. All right, so there we go. That takes care of that question. Let's jump back up here. And the homework, draw a rectangle with 2 circles shown below. The circles are tangent to each other. That means they touch at only one point, and they're tangent to the sides of the rectangle. Find the percentage of the area of the rectangle not covered by the circular regions. Repeat the process using 4 circles. Make a conjecture about the percentage of the area of any rectangle not covered by circular regions. Okay, well, so I need to go up here, and this was homework question number 7. So let me save that one, save online. circle in let's see here, a square in a circle in a square. Homework number 7. Okay, there we go. Let's clear everything off and we'll just start a new drawing. And here we go. We're going to build ourselves a rectangle. I don't know how I want to do this best. What would be kind of an efficient way to do it? Why don't I take a line to start with? So what I'm going to do is I'm going to use this line and I'm going to build the circles. And then once I have the circles, I'll build perpendiculars and I can build the rectangle around it. So that might be the easiest. What's the other way I could do it? Huh. I could do it where I try to build the rectangle and then build the circles inside, because I know the side length would be the diameter and I would need 2 diameters. So either way, you really could go either way. Let's see here. We'll build both of them and see which one we like better. Okay, so I'm going to start here. And what that means is I'm just going to build a circle this way and a circle this way. And that way I'm getting the same lengths everywhere. So I've got a point and a point. And then I'll do it again like that. And again, like, actually, I don't need this other one. I don't think I need this other one. There's 2 circles. See, if I hide this one right here in the middle, right? There's 2 circles right next to each other. So I could just make perpendicular lines up like this. Yep. And I'll get the end point over here. And then I'll also do perpendicular line here and here. That way we know exactly where to end it. Okay, so now the point that these intersect, I want a perpendicular line that goes that direction. And the point that these intersect down here, I need a perpendicular line going in the other direction. There we go. And so then my points around the outside are given here. Oops, you can see I turned blue, so I know it's not on where I want it to be. So I want it to be right on the intersections. There we go. And now let me hide a lot of those lines, because again, it just makes it busy. We don't need it to be too busy right now. There's a lot going on already. And there we go. And so now I can build, you know what? The area of the circles is going to be the same. So why don't I build the area of the circle right now? Now, if you want, because there's 2 different circles, you could make the area of both of them. You'll see it's exactly the same. But then I'll build my polygon next because it'll be easier to get my rectangle done if the circles are already done. And then I can just say, give me the area of that polygon. All right, let's take a look. So let's go measure it. Oops, wrong one. Wrong one. There we go. Click on the algebra tool. So let's see, what does it tell me here? Q1 is the polygon. A is the area of the first circle. B is the area of the second circle. So I need A, B, and Q1. So what I want to do is I want to create, let's see here. I want it to be kind of like a fraction. Let's see here. You know what, let's just type it in. So let's put parentheses A plus B divided by Q1. Okay, let's see here. There we go. Okay, that's the area that's used. And what was it asking for? Find the percentage of the area of the rectangle that is not covered by the circular regions. That is not covered by the circular regions. Okay, so I need 1 minus that. Okay, so I need 1 minus M. Okay, so 59.284. Okay, there we go. All right, you know what I'm going to do is I'm going to raise that up to the top. Let me try that other technique of building, and let's see how well that works. So here's the side. Now I build perpendicular lines here and here. I'm going to build the midpoint of the side, okay? And then do a perpendicular line to that one. And that way the centers of my circle are going to be on here. And now I need to do a circle with this center, okay? And what am I doing now? What I'm doing is I'm making this length right here, right there. That's the same length as that side. So that would be one diameter. I need two diameters. So build another circle with center and radius and create that point. And now I've got the rectangle that I want. Make a perpendicular line, build a new point, and there's my rectangle. So let me hide those objects. And this other circle, and maybe that line right there. Okay, let's take a look. Yeah, so there it is. So there's my rectangle. It's hard to see because I didn't put all the lines in. That's fine. And now I need my circles. So let's see if I can do that. I'm going to build a segment from L to O, and I'll build the midpoint. And then I'm going to build a perpendicular line. And I'll make a perpendicular line with N, and that will be exactly where I want one of my circles to be. So my circle with this center goes right here. There's one of them. And then I'm going to do the same thing, but this time I'm going to choose perpendicular bisector. I'll just pick perpendicular bisector of those two segments. And that right there is where my circle needs to go. And let's see here. Midpoint of those two, there's the point. So I can go from this center U out to the edge T, and it's going to hit perfect. Awesome. All right, so now I'll hit area. The area of this one is that, area of this one is that. They're identical. And then I'll build my polygon around the outside. And that is how you can do it a second way. Now notice on the first one, I can only move points A and B. So it seems a little weird to do points A and B. Oh, and I gotta hide my other objects. Burp, burp, burp. There we go. And this one, I can move the endpoints. And so maybe that feels a little bit more natural to move those endpoints around. Okay, let's get the area of my polygon. There we go. And we'll go back to the tool and kind of see what we get now. Let's see here. Okay, so I have U is the area of the first circle, V is the area of the second circle, and Q2 is my second one. So what I need is, I need U plus V divided by Q2. And let's see what we get. So U plus V over Q2 is this. And the piece not used is 1 minus W, which is 0.2146. Now that seems right. So something I think went not so great up here. HKJI. That looks all right. Why did I do A plus N in the first one? It should be A plus B. That's the problem. There we go. A plus B. Okay, there it is. So that was the issue. I was like, what the heck is going on? They should be the same. And there they are. 78.54%, 21.46. As you can see, I get the exact same numbers for both. Perfect. And I'm going to slide these over. And actually, I can kind of just make them a little bit smaller if I wanted to. Okay, and that's fine. Let's make this one a little bit smaller too. Okay, and then we'll click and drag it up there. Now it says do it for 4. Okay. Well, which one did I think worked better for doing with 4? I think maybe the second one worked better. So I'm going to do that again. So I'm going to make a segment like this. That'll be my rectangle. Then I'll make my perpendicular lines here and here. And I'm going to go to the right. I want to make 4 of them now, 4 circles. And let's see if we make a conjecture. And I do need that midpoint. So I need midpoint of this. and I need a perpendicular line. Oh, that's what I should have done. I should have done a perpendicular bisector of these 2 points. That would have done it. Okay, then I don't need to create another point. Now build my circle from W to V and make a point. Okay, so again, there'll be one circle in here. Then I'm going to make my circle from here to here. Okay, so there'll be another circle right there. Let's just put another point and we'll just kind of keep going. Circle with center radius there. Make another point. So that's circle number 3. And the last circle goes here. And that is circle number 4. So in order to get my rectangle, I need a perpendicular line here. And there's the point. Okay. And now all these circles that I had, all these big circles, they can go away. Okay, they're gone. And now I need perpendicular bisectors for each. So just take perpendicular bisector from W to Z, from Z to A1, from A1 to B1. And what I'm getting is where those intersect my center line is going to be the centers of circles. So make some points. And here come the circles. Start with the center, and I need a point here. There we go. So I'm going to go circle with center and radius. Here we go. Shh, boom. And oops, I need a point on the other end. Let's make a point there. Build my circle. There we go. And now I do need points where these touch so that I can build the other circles. And there they are. So now I'm going to go ahead and hide these other perpendicular lines. Again, they were helpful at the time, not so great right now. And that should get rid of them. There we go. So now I control this. I can make it be anywhere I want to go. I'm going to click on area. I'm going to find the area of each of these circles separately. They should be all identical. They are. Then I'll build my polygon around the outside from W to C1 to D1 to V and back to W. And then I'll just make sure I get the area of that polygon. Let's go back to the algebra tool and see if we can get the same thing. So let's see here. What do I have here? I have W1. Okay, so W1 is one of the circles. Okay, so O1, U1, V1, W1. Okay, and my polygon is Q3. O1, U1, O, U, V, W. Okay, well, here we go. O, oh wait, O1 plus V1 plus U1 plus W1. Okay, and all of that divided by Q3, I believe. There it is. And take a look. And 1 minus A2 becomes 21.46. We get the exact same percentage. So if you put a circle inside a square shape, you're going to lose this much. And basically, if you keep repeating it, and that forms the rectangle, they're all going to be exactly the same. So make a conjecture about the percentage of area of any rectangle that's not covered, and the percentage looks like it's going to be exactly the same. About 21% of it gets wasted. All right, let's save that one. Save online. Circles in rectangles. Area not used. Homework number 8. All right, there we go. All right, let's take a look. We'll clear this off and we'll go to the next one. Okay, I've got 11 and 13. All right, so 11, construct any ABC and its centroid, the intersection of the medians. Measure the areas of these other pieces. Okay, so when I build my triangle, I'm going to not want to make the polygon tool right away. And let's see how that works out. Okay, so I'm going to build 3 sides. Okay, and they can be moved anywhere. They're all in blue. All right, and then I want midpoints of those. So just click on the midpoints. Oops, that one missed, and you can see it's in blue. Okay, and then I need my segments that go from the point to the midpoint opposite. There we go. So this point in the middle is known as the centroid. Excuse me. Oops, let's see here. Measure the areas of ABC and its centroid is G. Is that good? Yes, it is. Centroid is G. Perfect. Then it says measure the areas of ABG, BCG, and ACG. Okay, so ACG. So I'm going to do A to C to G and then back. Okay, that's one of them. And it says measure the area of that. There we go. And what were the other one? I think BCG was one of them, right? BCG and ABG. Okay, so I'm going to do polygon, BCG back, and then BGA back. Okay, and now let's see here. If I click on one of these, I think what I'm trying to do here is just make it so it's very clear that there are 3 different ones in here. And that way I don't mix up, because they were all blue. It makes it a little hard. Okay. So here we go. The areas, ooh, look at that. Green area is the same as the red area is the same as the blue area. But let's check if I move these points around. They're still all the same. What if I bring them up? They're still all the same. I'll bring this point over. They're still all the same. State a conjecture concerning the areas of these 3 triangles. My conjecture is that the area of those 3 triangles is going to be exactly the same. That would be my conjecture. It didn't ask you to prove it, right? It did not ask you to prove it. It just said make a conjecture. And that's part of this. Part of this is maybe you don't have the tools to be able to do that yet. That's okay. But you can see something, just like your elementary school students can sometimes see something, even if they don't have all of the tools to be able to prove it in general. So very cool. Very cool. Now let's take a look here. What's even more interesting, to me, okay, so there's that one, is watch this. If I create a new triangle, and again, this triangle could be any triangle, that's why I'm choosing just 3 random points. I am going to do the midpoints one more time. And then I'm going to create those medians. Okay, centroid is the point in the middle. Very cool, right? But now, instead of doing the big triangles, I'm going to do each of these small triangles. And let's see about that. Let's see about that. What do you think is going to happen with each of these smaller triangles? Are they all going to be the same? Ooh, these ones on the right-hand side, they look a little bit bigger, so maybe they're going to be a little bit bigger. Okay, so I have now made it looks like one big triangle, but I'm gonna click on move. I'll right click and I can change the tone. See how I can do that? I can make it darker if I wanted to. That kind of does help. So previously, these 2 were together right up here. Oh, those are red. Ooh, you're right. I should keep this. So blue and blue. This one I'll change to red, and this one to red. That way it matches up here. And the other 2 were green. So I'll do green, and I'll do a thick green down here. Okay. Oh, I guess I should probably keep it consistent. I should do the darker blue over here and the lighter blue over there. That way it matches. It kind of looks like a pinwheel. All right, next up, we form areas. Here we go. There's the area of the first, the second, the third, the fourth, the fifth, and the sixth. So the fact that these three triangles are the same area is actually because their smaller pieces are all the same area, and each of these triangles up top is just two of those areas. That was pretty cool the first time I saw it because I was like, wait, what? How is it that I can make these shapes look so very different? And if you really want to know, here's why. You see this green area right here? It has a base. We're getting into this in chapter 13. It has a base. That base length is the same length as the length over here. And whatever the height is from this point going straight down, that would be the height of the triangle. And I want you to see that both OK and KH, using those as sides, would have the same height of the triangle because the vertex N is one of their points. So since they have the same height and the same base, the areas are guaranteed to be exactly the same. And that is pretty cool. And the same thing is true for all of those as you go around. So that's why this kind of cool fact happens. But again, it wasn't something that was needed. Okay, let's save online. Centroid and small triangle areas. Homework number 11. Very cool. And the last thing we have here is construct the centroid and its orthocenter and its circumcenter. All right. Now, this one may seem a little complex, but let's just go one step at a time. We'll clear everything. We'll start anew, and here we go. So I need a triangle. So I'm going to build a triangle. Okay. And what does it say? And it's centroid. Okay, so centroid means I need midpoints. That one missed. Let's try it again. There we go. All right, there's those points. I need the segments. And next up is just that point of intersection. So there's G. What I'm going to do now is I'm going to hide those other ones because, again, it just gets really, really, really messy very quickly because I'm about to do some other things. So G is the centroid. What's it say next? Then construct the orthocenter. All right. Orthocenter is the intersection of the altitudes. Okay, we haven't done that one yet, but let's see here. Altitudes are just perpendicular. So I need a perpendicular line from here to there. And I need a perpendicular line from here to there. And I need a perpendicular line from here to there. Okay, so I got to zoom out a little bit because where those intersect, oops, wrong one, is point H right there. Okay, perfect. Oops, bad. I'm choosing the point tool. I'm trying to move. Forgot to click the move tool. Okay, point right there. And that is H. Okay, so that looks good. So I have G and H. All right, and what does it say to do next? And the circumcenter O, the center of the circumscribing circle. Okay, so once again, I'm going to hide what I just used because, again, it's going to be hard to follow along otherwise. Now I need the center of the circumscribing circle. That is perpendicular bisectors. So I need a perpendicular bisector of this segment and the point down here. Oh, they called it I. What did he call it here? Oh, he called it O. Okay. Let's see here. Let's double click on this one and we'll go to settings. And I think I can change it. Oh, here we go. Okay, okay. I'll just change it to O in the settings. Okay, and now it's O. All right, got it. And so that's the circumcenter. And again, you can check. If I click here and go to any one of these, it goes through all the points. Perfect. Click escape and hide these other perpendicular bisectors I made just for that piece. All right. Now I have G, H, and O. Those seem to be the points I need to worry about. And let's see here. Yeah, so they do move around. As you can see, if I move A around, those points definitely move. It kind of looks like they stay in a line though. Okay, let's see what it says. Construct a line through O and G. Okay, construct a line through O and G. So I need line tool through O and G. There we go. And then it says drag your vertices around. What do you notice? Well, the line that goes through O and G, again, O is this one right here. The line that goes through O and G seems to always go through H as well. Do you see that? Huh. So, answer to the question, what is my conjecture? My conjecture is OGH. These points are collinear. I think they are collinear. Drag one of the vertices of ABC and state a conjecture about the ratio. Oh, I need a ratio now. OG to HG. Okay. So I'm going to go with a segment now. And what I'm going to do, this is my choice. I'm going to hide that line because it was cool, but I'm going to make segments now. I need a segment OG. Okay, and I need a segment HG. There it is. And now I can measure the distance or the length of those two pieces. And let's scroll all the way down to the bottom. Okay, OG is R, GH is S, so I want R over S. Is that what I want? OG over HG, yes. And the ratio, wow, the ratio is 0.5, which means that HG is twice as long as that. I wonder if that stays the same. So I want you to watch. The numbers are changing like crazy, but watch this area down over here where it says the A value, that ratio. That ratio is not changing no matter what I do. So the ratio is always 0.5. Well, now that is interesting. Huh. State a conjecture concerning the ratio. I conjecture that this ratio is going to be 1 over 2 the whole time. And it sure looks like it is. All right. That's it. So I will save this one as centroid, ortho, center, circumcenter line, work number 13. All right. So that takes care of the homework for Module H. I hope the video helped. Kind of shows you step by step how to do it. You may have to slow it down. I know I'm clicking fairly quickly because I'm trying to get through it. And once you get used to the tools, you can see what I'm doing and be like, okay, I get what he's understanding. All right, off you go.